Lithium, a key element of the current technological revolution, has become an essential component for our daily comfort. From our smartphones to electric vehicles to energy storage systems, everyone needs it. It is also a key element of the global energy transition, but the demand is such that the world could very quickly run out of them. Some automotive and technology companies are already experiencing supply problems and are storing their lithium reserves as real treasures. For example, the Japanese company Nikon can no longer ensure the delivery of all these products. But why does this shortage seem imminent? What are the solutions? We explain everything to you in this video. Since the manufacture of the first rechargeable lithium batteries for Sony cameras in 1991, the lithium-ion battery has been exported to many fields. Thus, it has become essential in the field of technology, electronics, aeronautics, and automobiles. But first, let's go back for a moment to what lithium is. This chemical element with atomic number 3 is an alkali metal that is part of the first group of the periodic table of elements. It is also nicknamed white gold because it is a central element in the course of the energy transitions of our modern societies. Indeed, it is the main element chosen by industrialists around the world to power the objects of our daily lives. Lithium is needed everywhere, but suppliers are no longer able to keep up, and demand will soon exceed supply by 10,000 tons. Often presented as an ecological component, we must not forget that lithium is mainly used by Chinese and American manufacturers. However, 70% to 80% of the global resources of this metal are found in Latin America, in particular in Bolivia, Argentina, and Chile, so it has a long way to go before it is used. In addition, its extraction consumes a lot of water, in addition to being dangerous. Indeed, if it is not properly controlled, it can create risks for local biodiversity. Already overexploited with increasing technological developments, but also global warming pushing us to find alternatives to oil, it may be even more in demand in the coming years. The concerns then begin to be heard, among industrialists as well as in the scientific community. Indeed, the very high demand for lithium is exploding, as long as the metal could enter a global shortage as early as 2025. This has many impacts, especially on electric cars. Delivery times are then extended. Car manufacturers face supply problems. Production slows down. Companies begin to stock up, and the price of a ton of lithium increases considerably, up to $22,000 per ton. But what are the solutions? As a first step, it will be necessary to improve the recycling of lithium. For example, in 2021, only 5% of lithium batteries were recycled. This will not make the shortage disappear, but it will make it possible to postpone the deadline. In addition, its recycling is essential because lithium can be harmful to the environment if it is not recovered and properly treated after its use. This would also make it possible to rebalance the distribution of raw materials on the territories at a global level. However, its recycling is still far from being the norm, and for several reasons. For example, the collection rate of batteries containing lithium is still low. Indeed, it represents only 10% of the existing volumes. This is also explained by low and volatile metal prices. While recycling can be expensive, even more than the price of primary production. Why such a high cost? Because this recycling is a real technical challenge. Indeed, lithium batteries are often composed of many other metals. Any cell of a lithium-ion battery is composed of 4 elements, which can be made of different materials. For example, in addition to lithium, for the positive electrode, there may be cobalt, manganese, iron, but also nickel and aluminum. On the other side of the negative electrode, we can find in addition to lithium, graphite, tin, but also titanium. These come in the form of chemical compounds, constituting small parts in a very small space, so it's difficult to recover them. In addition, the structure of batteries and accumulators differ significantly depending on the manufacturer, device, and model. It is therefore difficult to have a uniform and automated recycling process. However, things are starting to change. In France, for example, some companies have embarked on the recovery of lithium-ion batteries to extract lithium. For example, we could talk about the company Eurodeuze, which is a subsidiary of the SARP industry, belonging to the Veolia group. To recover the lithium, it uses a hydrometallurgical process. To recover the lithium, the metal is placed under a chemical solution after having been previously ground. Some scientists are also looking to develop less expensive recycling processes. Another solution to prevent the shortage of lithium is to replace the metal with more abundant elements. The most concrete example are sodium batteries. Indeed, there is at least 500 times more sodium than lithium in the Earth's crust. By being cheaper but remaining quite efficient, this revolution is taking place in China. It is more precisely the Chinese battery giant, CATL, the world's leading battery manufacturer, which has announced that its production line is ready. This would counteract the shortage of lithium, but also make electric cars more affordable. It would therefore be a real ecological asset. Keep an eye on sodium batteries, as they are still likely to evolve enormously and experience real improvements in the coming years. We can also talk about solid batteries, and more recently, lithium metal batteries by Korea Electrotechnology Research Institute, coming from South Korea, and also nicknamed Kirai. The latter are often assimilated to solid batteries because their stability seems to be able to be solved only by the presence of a solid electrolyte. Solid batteries use an electrolyte in solid form to limit the formation of dendrites. From there, it is conceivable to dispense with graphene to use other denser materials capable of storing more electricity, such as lithium. This makes it possible to store almost twice as much electricity as a lithium-ion battery, while aging less quickly because fewer dendrites are generated thanks to the solid electrolyte. Many companies are asking themselves the question, and the first batteries could be sold as early as 2024. However, non-solid lithium metal batteries on the other hand were not yet considered. But Kirai is changing the game by having managed to operate lithium metal batteries with liquid electrolyte by covering the anode with a sheet composed of a mixture of carbon and gold nanoparticles. Here, carbon prevents the formation of dendrites, and gold ensures good electrical conductivity. The result is a lithium metal battery that could be produced much faster than solid batteries. This could therefore quickly double the capacity of the batteries while extending their lifespan and doing without the graphene. It remains to be seen whether this solution will actually be able to be used in mass, and whether its cost will be competitive compared to that of solid batteries. But the shortage of lithium comes not only from the fact that this metal is little present on our Earth, but also from its misuse and distribution. This is such that tensions have arisen in particular with the European Union and the United States on the one hand, and China on the other. Indeed, the world markets today are mainly made of cheap Chinese electric cars. Their price is kept artificially low by massive public subsides. With Europe angry, they decided to open an investigation into subsides for electric cars in China. For example, the Chinese battery giant CATL, which we told you about a few minutes ago, causes consternation in the Western world because it produces many more batteries than it really needs, with a staggering figure of 1,500 gigawatt hours, when it needs only 636 for the needs of its domestic market. Yet, this does not seem enough for the Middle Kingdom. Indeed, an annual growth of 20.4% in Chinese lithium demand could take place, just for electric vehicles between 2023 and 2032, while on the other hand, the country's lithium supply will only grow by 6% each year over the same period. Yet, it is the third largest producer in the world. You should also know that even if more and more voices are raised about the imminent arrival of a lithium shortage, not everyone agrees about it. For example, Corinne Blanchard from the Deutsche Bank had explained to CNBC that even if the lithium shortage is real, it should arrive rather towards the end of the decade. She talks about a modest deficit of 60,000 tons in 2025. On the other hand, for 2023, it forecasts a hole estimated at 768,000 tons. We can also see that the number of lithium farms continues to grow worldwide. However, farms require a decade before they're really productive. A possible rebalancing of the market would therefore only take place in a third step. But the figure is so large that there could be a surplus of lithium in the next few years, which would make it possible to delay the shortage. On the other hand, subsequently, the scarcity of white gold seems inevitable. So, the shortage of lithium before the decade is real. Used in our daily lives, finding solution is essential. Several solutions are put forward, such as recycling, but also the use of sodium or even solid batteries. However, progress must be highlighted. To guarantee a sustainable and resilient future, it is time to take decisive measures to manage our resources responsibly and anticipate the challenges ahead.